Okay, so we're going to be recapping the rules of indices and applying them. So copy the lesson objective down, keywords, and when you're ready then hit play again and we'll move on to the starter. Okay, so here's our starter for today. Hit pause, have a go. When you're ready, hit play again and we'll go through them. Okay, so question 1. What fraction is equivalent to 60%? Well, percent means out of 100, so I'm just going to do that up here. 60 out of 100, and that's, I can simplify that because I can take 1 0 off the top and 1 on the bottom. So 6 out of 10, which simplifies further because I can divide by 2 and divide by 2 on the numerator and denominator. Okay, whatever you do to either the numerator or denominator, you have to do to the other, and that gives me 3 out of 5. In ascending order, smallest to biggest. Okay, we've got to compare percentage, fraction, and decimal. We've got to use either one, either percentages, decimals, or fractions. So we make them the same. Otherwise, we can't compare. 64% as a decimal, we use decimals. Is 0.64. 3/5 is 0.6, and we got 0.61. So the smallest is 3/5, and then we have 0.61, and 64% is the largest there. Recipe for 8 cakes uses 200 grams of butter, 120 grams of sugar. How much butter and sugar would you use for 12 cakes? Well, 8 goes into 12, 1.5 times, or 1.5. So you can simply multiply 200 by 1.5 and 120 by 1.5, which is fine. That works. Should give you 300 and 180. Or you could have a little table. We have the number of cakes and then how much butter you use and how much sugar. So if we create this little table here, now you know for 8 cakes we need 200 grams of butter. Oops, just rub that out. Not 20, we want 200. Get my pen back. So that's 200 grams and 120. Now 8 plus 4 gives me 12, so I'm going to put 4 here. 4 is half of 8, half of 200 is 100, and half of 120 is 60. If I add those together, that'll give me 12 cakes, 300 grams, and 180 grams. So same results as if we multiplied by 1.5. Either way, works out well. Find the mean and the range. Mean is when you add them all together and you divide by how many you've got there. 9 plus 3 is 12. 9 plus 3 is another 12. And then 4 out of 3 is 12. So 3 12s are 36. So the sum is equal to 36. And so the mean is going to be equal to 36 divided by 6, which is 6. And the range, biggest take away smallest, and that is 9 take away 3, which is 6. It's quite handy, they're already in order. And then finally, we've got 4a minus 5b minus 2a minus 3b. I'm going to need to write that at the top here because I've run out of room. So I've got 4a minus 5b minus 2a minus 3b. That's going to be equal to, so collecting like terms, 4a is minus 2a. Don't forget the sign is what's in front of the term. And then we've got minus 5b minus 3b. And you have to write it like this each time. Don't try and split them. Okay? Just write it like that the whole time. 4a minus 2a gives me 2a. and then minus 5b, minus 3b. So you're starting at minus 5, okay? Minus 3b gives me minus 8b. So be careful. Good. Copy that, any corrections you need. Don't rag rate it yet, because we've got a couple more questions. So make your corrections now, and when you're ready, hit play again, and we'll look at a couple more questions. Okay, 2 more questions for you. So hit pause, have a go. When you're ready, hit play again. Just label these. Well, on question 6, criticize the question. How often do you go to the shop? Whoops. How often do you go to the shop? Well, often is not a quantity you can define. So this is the problem with it, is vague. Okay, often doesn't tell us whether you mean how many you mean. Much better if we had a table to say, you know, in a week, once, 2 to 3 times. And then more than 3 times. Oh, yeah, more than 3 times. Good. Match the graph to the statement. Harry runs with constant speed at first. He then slows down to a stop before changing direction and accelerating back to his original position. And our answer is C, because he's got constant speed initially, slows down, stops, and then he accelerates. Okay. So he doesn't just take off with a constant speed, he slowly gets up to, he goes slow at first, and then he gets faster and faster as he goes back down. So C. Right, questions 1 to 7, make corrections, and now you can rag your work. Put a little comment there, anything that you need to follow up on. When you're ready, hit play again, and we're going to look at indices. So we're just going to recap the rules of indices as we've used them in the last 2 lessons. Okay, first one was the multiplication rule. And we're just going to use real examples. So if we had, say, 3 to the power of 2 times 3 to the power of 3, as it says here, got m and n, we add the indices. So that's going to be equal to 3 to the power of 2 plus 3 equals 3 to the power of 5. And you can imagine if you had, say you had letters. So you had x to the power of 3 times x to the power of 4. It's going to be x to the power of 3 plus 4 equals x to the power of 7. Division rule. So with numbers and n terms, so if we had, say, 5 to the power of 4, oops, not 54, 5 to the power of 4, let's get rid of that. 5 to the power of 4, say, divided by 5 to the power of 2. That's going to be 5 to the power of, so division rule means we subtract. So it'll be 4 minus 2, which is 5 squared. And if we had terms, so x to the power of 7 divided by x to the power of 2, that would be x to the power of 7 minus 2, which is x to the power of 5. Then we have the power rule. Okay, so we have here a to the power of m, and then in brackets to the power of n, and we multiply the indices. If we had, say, 2 to the power of 4, and we square it, that's 2 to the power of 4 times 2, which is equal to 2 to the power of 8. If it was a term, x cubed, that would be x to the power of 3 times 3, which is x to the power of 9. Then we had a negative index rule. Okay, so if we had, say, 4 to the power of minus 2, remember it's the reciprocal of it, so it becomes 1 over. So 1 over 4 squared. And 4 squared is 16, so it's 1 over 16. You can do the same thing if it was a term. Y to the power of minus 3 is equal to 1 over y cubed. Because we don't know what y is, we leave it in that form. Okay, and we know that anything to the power of 0 is 1. So let's make some notes then. Let's write these down. We have had previous examples. Let's copy these down into as our notes, and then we're going to use them to answer some questions next. So hit pause, copy them down. When you're ready, hit play again. Right, some quick recap for you. So write classwork down, and when you're ready, you may begin. Oops, don't want you to see that. And the first one is an example. You should be writing is equal to y to the power of 2 plus 3 equals y to the power of 5. Okay. Hit pause, attempt the questions. When you're ready, hit play again, and we'll go over the solutions then. With the numbers on number 2, what do? Well, you multiply the numbers first. So you do 2 times 3, which is equal to 6. And then you got y to the power of 2 plus 4, which is y to the power, 6 times y to the power of 6. Okay, let's go through the solutions then. We got 1 and 2. For number 3, you should have 30p to the power of 6, because you have 5 times 3 times 2, which is 30, and then p to the 2 plus 3 plus 1. Okay, 48k. And then we got 2 terms here. So what we've got is a to the power of 1 plus 2 plus 2, so a to the power of 5. And then we've got b to the power of 2 plus 3, 5 plus 4, which is 9. Okay, good. Question number 6, you should have 12a to the power of 6b to the power of 8. And then here we're multiplying the indices. Don't forget that it's 2 squared as well, so it's going to be 4. And then p to the power of 2, q to the power of 4. Okay, let me check out our other answers. 9a to the power of 4, b to the power of 6. Number 9 is 25, m to the power of 4, n to the power of 6. Okay, this is cubed now, so it'll be 2 cubed, which will give you 8, p to the power of 3, q to the power of 6. Okay, number 11, 81, a to the power of 8, b to the power of 12, and number 12, 32, m to the power of 10, n to the power of 15. Okay, so make your corrections, and I've got some classwork for you to do. So hit pause, make your corrections, and we'll have a look at the classwork. Okay, so this is our classwork for today. Question 1, you got a, 5 squared times 5 squared, and so on. So I'm going to attach these questions to the assignment.